Space is the final frontier, as they say, and for good reason. We can look up and see the stars, planets, and even our own moon. But the vastness beyond is still full of unknowns. Today, we're going to explore some of those mysteries, the mind-bending things scientists are still trying to figure out. So, grab a metaphorical spacesuit and get ready for a journey into the unknown. In space, no one can hear you scream. This chilling tagline from the movie Alien perfectly captures the eerie silence of the cosmos. Imagine drifting through the infinite void, surrounded by an oppressive quietness so absolute that even the most primal cry for help vanishes into nothingness. The thought alone is terrifying, adrift in a soundless abyss, where silence itself becomes a sinister, ever-present companion. Space is teeming with silent killers lurking in the vast darkness. Asteroids, like celestial predators, drift through the cosmos with lethal potential. These silent assassins move without a whisper, their paths unpredictable, capable of obliterating entire civilizations upon impact. Consider the near misses we've experienced. In 2013, an asteroid named 2012 DA14, roughly the size of an Olympic swimming pool, passed just 27,700 kilometers from Earth, closer than many of our satellites. More recently, in 2020, asteroid 2020 QG skimmed past us less than 3,000 kilometers, the closest flyby ever recorded without impact. These close encounters remind us of the lurking danger. The terror lies in their silence. A colossal asteroid could be hurtling towards us right now, an unstoppable force cloaked in the stillness of the cosmic night. The distance between Earth and the Moon is an impressive 384,400 kilometers, a vast stretch of space that can accommodate all the planets in our solar system lined up side by side. This fascinating fact highlights the immense scale of a celestial neighborhood. Imagine looking up at the night sky and visualizing Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune, all fitting neatly within the space separating us from our lunar companion. This mental image offers a captivating perspective on the distances and sizes of the planets, showcasing the remarkable vastness and harmony of our solar system. The biggest star known to us is UY Scuti, a red supergiant located in the constellation Scutum. UY Scuti has an estimated radius 1700 times greater than that of the Sun. This red supergiant is the biggest star we've ever seen. If you hollowed out UY Scuti, you could fit nearly 5 billion suns inside it. That's right, billions. To put this into perspective, if UY Scuti were placed at the center of our solar system, its outer surface would extend beyond the orbit of Jupiter, engulfing the inner planets and much of the asteroid belt. Astronomers believe a specific type of star, a white dwarf, can actually transform into a giant diamond over time. Here's the mind-blowing part. This celestial diamond could weigh in at a whopping 10 billion trillion carats. That's a 10 with 21 zeros after it. To put that into perspective, the largest known diamond ever mined, the Cullinan diamond, weighed a mere 3,106 carats. So this cosmic diamond would be millions of times bigger. Although we can't exactly hop on a spaceship and snag a piece, it's a fascinating example of how nature can create incredible things even on a cosmic scale. Our giant leap for mankind left some seriously long-lasting marks. The footprints left by the astronauts on the Moon during the Apollo missions are expected to be visible for millions of years, maybe even as long as the Moon itself exists. That's because the moon has no atmosphere, which means there's no wind or rain to erode them away. It's like a giant cosmic time capsule, permanently preserving these historic steps. Pretty cool, right? A day on Venus isn't just a little longer than usual, it's downright weird. It takes Venus 243 Earth days to complete a single rotation on its axis. That's almost twice as long as a whole year on Venus, which lasts only 224.7 Earth days. Here's the crazy part. Venus is said to have a retrograde rotation, meaning that it spins the other way around. This makes it that the sun actually rises in the west and sets in the east on Venus. Imagine a sunrise that looks like a sunset and vice versa. That's Venus for you. So if you ever go on vacation to Venus, which with its scorching temperatures and crushing atmosphere probably isn't the best idea, forget about catching a sunrise. You might be waiting a very, very long time. Astronomers have discovered the largest and most distant reservoir of water ever detected in the universe. This cosmic water fountain surrounds a quasar, which is a supermassive black hole actively feeding, a whopping 12 billion light years away. The amount of water vapor detected is truly mind-boggling. It's equivalent to 140 trillion times all the water in Earth's oceans combined. This discovery suggests that water may be much more abundant in the universe than previously thought, even in the presence of these powerful quasars. There's a famous formula used by astronomers to estimate the number of civilizations in our galaxy that could potentially communicate with us. It's called the Drake equation, and it looks like this. Here's the interesting part. Most of these factors are complete unknowns. N stands for the number of cosmic civilizations out in the Milky Way, with the technology to communicate with us. We can estimate the rate of star formation, R, and maybe the fraction of stars with planets, Fp. But the rest? The number of planets that could support life, Ne. The chance of life arising on those planets, Fl. The chance of that life becoming intelligent, Fi. The chance of them developing detectable technology, Fc, and the length of time such civilizations survive, L. These are all huge mysteries. The Drake equation is more of a tool to spark discussion about the potential for life out there, rather than a way to give a definitive answer. It highlights just how much we have yet to learn about the universe. Right now, a Milky Way is slowly merging with several smaller galaxies, like crumbs being pulled towards a giant cosmic cookie. These are called dwarf galaxies, and they don't stand a chance against our massive Milky Way. The gravitational pull stretches them out, and eventually their stars become part of our galaxy's swirling disk. But the real showstopper is yet to come. The Milky Way is hurtling towards the Andromeda Galaxy, our biggest neighbor, at a mind-boggling speed of about 400,000 kilometers per hour. The Milky Way is definitely not lonely when it comes to galactic interactions. In a staggering 4.5 billion years, these two galactic giants will collide in a slow-motion ballet, eventually merging into a single, supersized galaxy, Milkomeda. Hello everyone, thank you so much for watching this video. If you enjoyed this type of content, consider supporting us by liking the video and subscribing to the channel. And with that being said, I will see you all in the next one.